Astronomers once assumed our solar system was ordinary. It seemed like a safe assumption. We had 4 small rocky planets close to the Sun, giant gas worlds farther out, and nearly circular orbit keeping everything calm and predictable. For centuries, we thought this was simply how planetary systems formed. Then we discovered thousands of others, and everything changed. Instead of orderly systems like ours, astronomers found chaos. Giant planets skimming their stars, tightly packed planetary swarms, worlds migrating through space like gravitational wrecking balls. The more systems we observed, the clearer it became. Our solar system doesn't look typical. It looks suspiciously tidy. If our system really is unusual, then something must have gone wrong with the standard blueprint for planetary systems. And the first clue is a missing piece, a type of planet that appears almost everywhere else. Across the Milky Way, the most common planets aren't Earth-sized. There are super-Earths and mini-Neptunes, planets between about 1.5 and 4 times Earth's mass. Astronomers find them everywhere, often tightly packed around their stars in dense inner systems. But look at ours: Mercury, Venus, Earth, Mars, and then nothing. There's a vast gap before the gas giants begin. Statistically, roughly half of Sun-like stars host these middle child planets, yet our system doesn't have a single one. That absence matters. Large inner planets tend to destabilize smaller ones, scattering them, colliding with them, or preventing them from forming at all. Systems crowded with super-Earths are often dynamically violent places. Our inner solar system was given something rare: space. Space for a stable orbit, space for planets to remain undisturbed, space for one small world to stay habitable for billions of years. Our system didn't just form differently. It formed with a gap where planets usually are. But empty space alone doesn't explain our existence. Because even without those planets, there was still something else that should have destroyed everything before Earth ever formed. Many giant planets we observe in other systems behave badly. They travel on elongated orbits or plunge inward toward their stars as hot Jupiters, disrupting everything in their path. For a long time, we assumed our Jupiter had simply stayed put since birth. But planetary models suggest something far more dramatic. Early in our solar system's history, Jupiter likely began migrating inward toward the Sun. As it moved, its immense gravity would have scattered or consumed the material that was supposed to become the rocky inner planets. In other words, Earth may never have had a chance to form at all. This scenario is known as the Grand Tack hypothesis. According to it, Jupiter's inward plunge was halted only when Saturn formed and gravitationally locked with it. The two giants entered a kind of orbital tug-of-war, pulling each other into a new configuration that pushed Jupiter back outward again. A perfectly timed rescue. Had Saturn formed slightly later or slightly smaller, Jupiter might have continued its inward dive, clearing out the inner solar system and leaving nothing behind but debris spiraling into the Sun. We don't just have a stable giant planet. We have one that was stopped at the last possible moment. In other words, our solar system survived a catastrophe that should have been final. And yet, even after that near disaster, the violence wasn't over, because the planets we see today still carry scars from a time when collisions ruled the young system. If our solar system seems calm now, that's an illusion. It is the aftermath of a battlefield. Consider Venus. It rotates backward, opposite the direction of most planets, and so slowly that a single day lasts longer than its entire year. Something enormous must have struck it long ago to flip its rotation. Then there's Uranus. Uranus doesn't merely tilt, it lies on its side as if knocked over. Its poles point toward the sun. To tip a planet that large requires an impactor roughly the size of Earth striking it at tens of thousands of miles per hour. These aren't minor irregularities. There are fossil evidence of planetary scale violence. Our solar system didn't gently assemble itself. It survived repeated cosmic disasters. These are the marks of a system that barely made it through its own formation. So when you line up all three facts together, something unsettling emerges. We are missing the most common planets in the galaxy. Our largest planet nearly destroyed the inner system before it began, and the worlds that remain show signs of catastrophic impact. Individually, each of these would be unusual. Together, they form a pattern that's hard to ignore. Most planetary systems we've discovered are messier, tighter, and more chaotic. Ours looks improbably fortunate. There's an idea in science called the anthropic principle. It suggests that we observe this strangely stable system not because it's typical, but because only a system like this could produce observers at all. In most of the universe, chaos wins. Somehow here it didn't. And that quiet, unlikely stability is the only reason we are here to notice it. By every expectation, our solar system shouldn't look like this. And yet, it does. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.